So once again I will explain here. Ray optics means, first optics, what is mean by the optics? So it is the branch of the physics which deals, will study about the nature and productions and propagations of light. How the light will travel in the one medium to another mediums, what is the behaviors, okay, and what is the nature of productions of images, all will discuss about in this ray optics. So first we have done here the behavior of lights at the interface of two mediums. When the light will travel from one medium to another mediums, so three things will be happen. Three effects may occur. First one is a part of incident light is turned back to the first medium only. This is called as reflection of light. Like this one here, if this is the incident ray here with the angle I from normal it's going on. This is the normal lines. So the angle of incident is I. So this incident ray is striking with this second mediums. This is the medium here. Is one medium to another medium system. Some part of the light is coming back to the same medium, first medium only. This is called as reflection of light. This is called as reflection. And some part of the incident light is transmitted back to the transmitted into the second mediums, along with change in direction. Maybe it will go towards the normal, yeah, away from the normal. Okay, so this is angle is called as R. Okay, this is refractions. This ray is called as refraction, which going to the second mediums, and the angle of this R is called angle of refractions. And remaining part, remaining part of the light is absorbed by this second mediums. That is called as absorption of light. Okay, till here any doubt? So law of reflections here, the angle of incident, that is, let's consider angle of I here, that will be equal to angle of reflections. Okay, so you can write here angle of reflection is R. So angle of I is equal to angle of R. And second you can write here the incident ray, the normal to the mirror at the point of incidence, and the reflected ray lie in the same plane. Okay, so this is the angle of, this is called as law of reflections. So angle of incident is equal to angle of reflected. Incident ray, reflected ray, and refracted ray all lie on the same plane. Okay, so this one you can see here, this is the plane here. So this incident ray, reflections, and this refractions all lie on the what? Same plane only.
Same plane.
Yeah. Sign convention. So consider any here mirror is given here. So just like a axis only you can write it here. Okay, this is the origin you can assume. So this side all will be what? This side whatever is given incident light here. This is the object will be placed here. Upward will be positive, right?
Yes, sir. And downwards will be negative.
Negative. Height upward is positive. Half this one high, downward will be negative. Now here distance, this side, distance against incident light. distance against incident light is positive, and if you're going away here along the incident light, that will be negative. Distance along incident light is negative. Okay, so
Yes.
so all the distance will be measured from the pole. This is the pole P. We have studied in the lower classes, right? All the distance measured in the same measured form, the pole of the mirror.
So object distance will be considered negative, no, then, because it's along the.
A spherical mirror what is a spherical mirror here? A spherical mirror is a reflecting surface.
Should I write this down right now? Should like you'll write it first, you'll explain, and then I'll write.
I will explain first.
Okay, thanks.
A spherical surface is a reflecting surface which forms part of a hollow sphere. So there are two types here. One is called as concave mirror, and second is convex mirror. Okay, so both narrow beams, whether in the concave mirrors or convex mirror, I consider this is two mirror is there. Okay, so this is concave mirror will be colored by the outer part like this, and convex mirror will be colored from the inside. This is called as principal axis. This is the principal axis, and this is the pole here P. So if any narrow beams of light parallel to the principal line, if you pass it here, so it will be reflect from the mirror and it will pass from the focus. This is what focus here F.
Alright.
So any parallel line, like this is the one parallel line, this is another parallel line, if you pass it here, this is also will pass from the focus only.
Yes, I got it.
Similarly, in the case, this is a concave mirror. Similarly, in the convex mirror, if you pass any beam of light which is parallel to the principal axis, so it will collide it and it will be create a imaginary focus here. This is the focus here. Similarly here also, this is the point is focus here. So if any narrow beams of parallel light parallel to the principal axis, if you pass here, either it will be converge or diverge. So this is converging here, okay, and this is here diverging it from the point focus F, okay, on the principal axis.
So convex diverges, concave converges.
Yeah.
Okay.
So this point at principal axis is called as focus.
Yes, I got that.
And this concave mirrors having the real focus. This is the real image. After the reflecting, it's coming to the focus here, right? And this is the imaginary line. Okay, if another light will also will pass here, so this will also
same imaginary focus will pass.
Focus only. So this will be the imaginary. We also called as virtual focus.
Yes, good.
The next is relationship between the focus and radius of curvature. Okay, so this is the I have taken as a concave mirror here, and the light is passing from parallel to the principal axis, and it will goes from the focus. So now this is, let's consider center of curvature. Center of curvature means the optical sphere radius. Okay, so this is I am drawing it here.
Yes.
Angle of bisector here. So this angle incident ray I, and this is the R here, that will be the same only, right? This I am assuming it theta here. So this is also is opposite angle here. Okay, this is the angle of I and angle of theta is same only, right? Here this I can write the point here. This is A, B, and this is F here, and this is D. This is the pole. This is M dash M. So we can consider this M dash is the mirror here, and this AB is parallel to the CP. AB is parallel to the CP means this ray right is parallel to the principal axis. Okay, so alternate interior angles will be equal here. So angle of ABC is equal to angle this FCB, I can write it. This is opposite angle, right?
Yes, sir.
And this will be same as angle of I is equal to angle of R, because this I and R is the angle of bisector. So therefore we can write it here, angle of I is equal to angle of R, and that both equal to angle of theta.
Yes, sir.
Now this FC, this F and C is equal to F and B, because we know that opposite side to the equal angles are equal, right?
Yes, yes.
We know that. Sides opposite to equal angle are equal. So I can write it here, FC is equal to F of this, FC is equal to F of B, and that will be same as FC is equal to F of B, that equal to same as F of P, this focus to pole. Okay, so CP is equal to, I can write CP from here to here, CF plus FP. Okay.
Yes, sir.
That CP is equal to FC, and this FP also I can write FC only. So it becomes 2FC.
Yes.
Any doubt till here? Or
No, sir.
CP is equal to, also I can write 2FC, that is equal to FC is equal to same as FP also. So 2 into F into P. What is CP here? CP is radius from here to here.
Yes, sir.
So this is radius here is equal to 2 into FP. FP is, this is a focus one. 2 into F. So I can write therefore F is equal to R by 2. So next is the mirror formula here. We have taken the concave mirror here. AB is the object here, which is the, consider the height something, and the line parallel to the principal axis is passing from the focus, and one is directly it's going to the pole, and one
Yes.
one ray is going from the center, and they are forming the image as A dash B dash. Okay,
Yes.
this is
Yes,
the
sir.
point D here. So now here you can write here, this is object here, so object distance is from here to here. I will write with different color here. This object distance from here to here, that is what, let's consider this is U. Image here, this is the image here from the pole, that is what, let's consider this is the V. And here
Yes.
focal length will be here from this to this point is F. Okay,
Yes, sir.
so we can write it here. The three ray is passing here. The ray from the point which is parallel to the principal axis, the refracted rays goes through the focus of the mirrors, and the ray passing through the center of curvature of the concave mirrors, it's appearing and passing through the this point,
Yes, sir.
and forming the image as A dash B dash. So in this figure you can write in triangle here. In triangle, all the theoretical explanations you can write it here. Okay, just triangle A dash, B dash and F. This A dash, B dash and F, a small triangle, this one. Okay, this.
Yes.
And triangle MPF. This M, P and F. This is also just like a straight line only. Okay,
Yes, sir.
this triangle here.
Can you just drink some water and come?
So this one will finish it first, then you can go. This
Okay,
triangle
so
you can
you
write
can
similar here, so we can write B dash A dash, that is by PM, that will be the same as B dash F by B dash F, this one by FP. Both are similar here, so ratio will be the same. Okay, and PM, this PM is same as BA. Okay, PM is equal to, I can write same as BA. So I will replace in the place of PM, that is B dash A dash by BA, that equal to same as B dash F by FP. This one let's consider equation number 1. Okay.
Okay.
So now you can write it in triangle here. A dash, B dash, P. This one A dash, B dash and P. This triangle only is a smaller one. And this triangle A dash, B dash, A dash, B dash, P and ABP. A, B and P. This one triangle. This one A, B and this whole bigger one. Okay. This triangle. So this one you can write it here. B dash A dash by BA, that same equal to B dash P by BP. This one B dash P by BP. This B and P. Any doubt till here?
Yes.
So now here you can compare the equation 1 and 2. This left hand side is same here, so right hand side also I can write same. From 1 and 2 you can write B dash F by FB. FB or FP, anything here, this one both are same only, right?
Yes, sir. B dash. Okay, yeah. So it'll be small f, no, then because you've written small f in the diagram for FP.
B dash F is what? B dash and F is this one here. I can write it B dash P minus FP. Okay, from this distance here I can write it total distance minus FP. Okay, this one is equal to what? B dash P by BP. I will write it in the next step. that I can write b dash f, I can write it here, this one here, that is b dash p minus fp divided by fp, that equal to same as b dash p by bp. Any doubt till here?
No doubts, no doubts.
Now you can substitute the values here. What is the b dash p? What is the b dash p here? B dash p is the distance of this image v, right?
So B, yes.
B dash p is the image here, and this is the minus v because lower side is there, right?
Yes, sir.
fp, f and p is the focus here. Focus is also is down here, minus f, and bp is equal to this b and p from here to here is equal to object here, right? That you get minus u. You substitute these values here, you will get it minus v minus become plus f divided by minus f, that equal to minus b dash p is equal to v, and this is minus u. So this can cancel here. I can write, if you multiply with minus here, I can write v minus f by f is equal to v by u. Okay, so this by this and this by this, if I will write it here, I will get it here 1 by v plus 1 by u, that is equal to 1 by f.
Alright. Mirror.
So this is the mirror equations. Now we'll see the linear magnifications. Linear magnifications, that is represented as a small m. Okay, it is the ratio of height of image to the height of object. Height of image, that is represented as h dash, and height of object, that is h. So m is equal to, I can write it here, that is h dash by h. That also is equal to the v by u, and you have to write the sign convention here. This is with sign convention. So for the concave mirror, you know that v is what, negative here, minus v by u will becomes for concave mirror, because the concave mirror will get the real and inverted image, right? And for the convex mirror, v, m is equal to v by u only, positive for convex. This will be get
So for concave, 1 second.
This will be virtual and erect image, and this will be
Yes,
real
sir.
and inverted.
So for convex, sir, what do you call, since we...
Now the formation of image. By concave, first we will see the concave mirror. So first one, let's consider this object is placed on the object beyond C. Like this is the concave mirror here. This is C. Object is placed beyond the center of curvature here. So if parallel lines will be there, three lines there, three rule is there to draw it. Line principal to parallel to the principal axis, that will go to the focus, right? And if you pass from the focus here, that will form here, this one here. So this is the image here. This is the focus F here. This will get the image. Let's consider this image is I here, and this object is OA. So we can write it here. If the object beyond the C, the image is between the C and F. This is A and this is F here. So the image will be in the between the C and F. And that will be real, inverted, and a smaller than object, because this is very a small object here. Image is forming here. A smaller than object. Now let's consider in the second case here. If the object is placed on the C, object at C. So this is the center of curvature here, and here object is placed. So this parallel to the principal axis line, it will pass from the focus, and the line directly is going for the focus here. That will meet at the this point only. If this is the object here O and A, so image also is forming at the center only. If object is placed at C, then the image is at C, and that will be your real and inverted. And you can write here, this is the same size of the object only.
Okay, sir. Yes, another thing.
If object between the F and C, so this is the mirror here. This is the center here. This is object is placed between this. This is F, between the C and F here. So here you pass the line parallel to the principal axis. You go from the focus like this, and directly from the pole we'll cut it somewhere here. Okay, so this is O and A is the object here. Image will form at the here. This is the image here. So you can write here, if object is placed between the C and F, the image is beyond
C, real, inverted,
real,
and bigger. I think it'll be larger than the
larger than the object. If object is between the F and P, first write object at F only. So object at F here, this is C, this is F. So if object is placed here, so the image will pass from the here, focus on it and will go parallel here. Getting?
Yes, sir.
So this one will be image is enlarged. Inverted, and you can write infinity. At infinity this will be. And this will be also real only, okay?
Yes, sir.
And if object is between the F and P, if you place last one, between F and P. This is C, this is F. Here object is placed here. Okay?
Yes, sir.
So this will be inverted here. Okay? This will be the image will be come at here, other side. This is the image. You can write here image will be behind the mirror. This will be virtual.
Virtual laterally inverted and behind the mirror.
And that will be larger than object. So this